Hello, in this video I'm going to solve the problems in homework number 8. Question number 1. The following figure portrays a part of the graph of the function y equals to a times cosine bx plus c degrees plus d, where a and b are both positive. If c is chosen such that it is the smallest possible positive number, then a plus b plus c plus d is indeed wanted. Okay, to open up a little bit of a space, let me take the graph to the next slide. Okay, since it is mentioned in the problem that a is positive, the formulas that we learned during the lesson for capital A and capital D applies. What were these formulas? A was y max minus y mean divided by 2, and then D is y max plus y mean divided by 2. So what we need to do now is to read y max and y mean from the graph, which is an extremely easy task. Okay, so you see that the highest point of the graph is here, so if I want to write its y coordinate, I should go horizontally and read this number. But that's also simple, 1, 2, 3, 4, 5, 6, 7. So y maximum is indeed 7, and y minimum occurs here, which is clearly minus 1. Okay, so I go here and put them in this formula. Y max 7 minus y mean is minus 1 divided by 2. So it becomes 8 divided by 2, 4. So A simply becomes 4. Now for D, it becomes y max, which is 7, plus y mean, which is plus minus 1, divided by 2, 6 divided by 2, or 3. So this means that D is 3. Okay? So for B, you learned during the lesson that we have to find the period. For example, the period is the distance between two consecutive crests or two consecutive troughs, but they are not available in this graph, in this picture. But I have the access to the crest and an immediate trough after that. I can find the horizontal distance between these two, and then I have to remember to multiply that by 2 in order to get my period. Okay, so this point corresponds to this point on the x-axis, and this point corresponds to this point on the x-axis, and the distance between them is this much. How much is that? It is 1, 2, and 3 grids. So I need to know how much is the length of one grid. So here I see that 2 grids is minus 40, of course, because it is in the negative direction, it's minus 40, but the length of each grid is 20 degrees. So the period is 3 times 20 degrees, because between them I have 3 grids, but this is half a period, so to find the period I multiply it by 2. So the period 2 times 3 times 20, it becomes 120 degrees. But I have a formula that T is equal to 360 degrees over B. So I put T equals to 120, and from here I can immediately find what B is. The B also here becomes 3. Now, if you remember during the lesson, I told you that at this stage it might be a good idea to put these numbers you found so far in the problem and then try to find C. Okay? Okay, I forgot to put a degree sign on C here. So y becomes equal to A, which is 4, cosine B, which is 3, x, and then I have plus C in degrees, plus D, which is in this case again 3. Okay, in order to find this C, I have to consider how much shift on the horizontal axis has done to this graph compared to the underlying trigonometric graph. The underlying trigonometric graph here is the graph of cosine of 3x. So I have to have a good idea of the graph of cosine 3x. In order to do that, I will draw the graph of cosine x, which is a standard one. You should have it in your memory or be able to reconstruct it more or less easily. Okay, so what is the graph of cosine x? So this graph that you see, let me make it a little bit smaller. This is the graph of standard function cosine 3x, sorry, cosine x. Okay, so this is the graph of the function cosine x. This we should know. Okay, and then for cosine 3x, I have to squeeze it by a factor of 3. So what does it mean? It means that this point, which is 90, will be squeezed by a factor of 3, so now it becomes 30 degrees. And this point, for example, is minus 90 degrees, now it becomes minus 30 degrees, and this point becomes minus 60 degrees. So everything will be squeezed by a factor of 3, yes? And now you compare that. This is the first trough on the left hand side of the y-axis, okay? And then this is the first trough on the left hand side of the y-axis. This, the original one for the function of cosine 3x, of course, occurs at minus 60, but for this one it occurs at minus 40. So what does it mean? It means that I have to shift this graph 20 degrees to the right. Okay, but how much is, so I realized by comparing the graphs that the shift is 20 degrees to the right. 20 degrees to the right is the shift, so it means that I have to write it as minus 20 degrees because the shift to the right corresponds to negative values. Okay, but what is, this is the observation shift that I make by comparing graphs. But what is the theoretical shift? This is not c degrees, be careful, because c is added to 3x. I need to know how much is added to x itself. So what should I do? So this will motivate me to write 4 cosine, but instead of writing 3x plus c degrees, I factor a 3 out. It becomes x plus c degrees over 3, and then of course I will have a 3. So the amount of shift is c degrees over 3, which should be minus 20. But let me deviate a little bit from what I told you during the lesson. This is of course not wrong, but let me change my strategy. Instead of finding one of them, I want to find all possible shifts. Okay, this is one of them, but if I want to find all possible shifts, I should add actually a multiple of the period of the function to this value as well. Because if a function is periodic and I am adding any multiple of that period to the function, I will not change my function. Okay, so what do? I will write plus n times the period of the function, but as you see the period of the function was 120, so I would write 120 degrees. Now I multiply everything by 3 and I just take the degree sign away, so c becomes minus 60 plus n times 360. Okay, and then n belongs to z, of course. What does this mean? It means that these numbers generated by these formulas are all possible shifts along the x direction. But the problem, so if there is no constraint given in the problem, you just name one of them. For example, I can put n equals to 0, I get minus 60. For example, I can put n equals to 1, I can get 300. But here, because I'm looking for the smallest positive one, I have to choose n equals to 1 because negative n's gives negative values for c which are not acceptable, and if I go beyond n equals to 1, of course I will get correct answers, but those are not the smallest ones. So the smallest one occurs when n is equal to 1, then it means that c is equal to minus 60 plus 360, which is 300. And then it means that the question mark, which is the sum of a, b, c, and d, it becomes 4 plus 3 plus 300 plus d is also 3, so it becomes 310, and that will be the answer to this part of the problem. Okay, so now let us go to the next problem. Problem number 2. The following figure portrays a part of the graph of the function y equals to a times sine bx plus c degrees plus d, where a is negative, b is positive. If c is the greatest possible negative number, then a plus b plus c plus d is equal to what? Moreover, the amplitude of this function is also wanted. Again, let me take the picture with me to the next page. Okay, here, because a is negative, the formulas that we got in the lesson for finding capital A and capital D needs a little bit of modification. So let us try to understand that. If I ask you how do you maximize y, in this case that a is negative, if you increase this part, because a is negative, you are not increasing y. In contrary, you are decreasing y. So if this is negative, in order to increase y, you have to minimize this part. Yes? Okay, so this means that y max occurs when I choose -1 for sine. So then it becomes minus a plus d. And of course, then it becomes clear that y mean becomes a plus d. Okay, because this time I have to choose the maximum possible value for sine, so that being multiplied by a negative value, it becomes the minimum possible value and minimizes my y. And of course, if I ask you what happens if I add them, when I add them, the left-hand side becomes y max plus y mean. These are gone. D plus d becomes 2d, and when you divide by 2, you get exactly the same formula as you had before. No changes. But now, if you want to find a, first you multiply this by minus sign, it becomes positive, then it becomes negative. And then you add this to this side by side. These are cancelled now, a's are added now, but I will have y mean minus y max, so I have to divide it by 2. So there would be a very slight change in a. Instead of y max minus y mean, I will have y mean minus y max divided by 2. Okay, so these are the formulas for the case that a is negative. D is exactly the same, a is just the other way around. Okay, so then I have to read the maximum and minimum values of y again. So maximum occurs here at this point, so 1 grid, 2 grid, 3 grids, so that y max is 3 and y mean is indeed here, and that is just 1 unit. So y mean is -1, y max is 3, so then it means that d is equal to 3 plus -1 divided by 2, which is 1, and a is -1 minus 3 divided by 2, which is -4 divided by 2 minus 2. So yes, that is correct. You see, a automatically becomes negative value, which is acceptable, and d becomes 1. Okay, again, b is related to the period. So this is one crest, and this is one trough. So I need to see what is the horizontal distance between them. 1 grid, 2, 3, 4, 5, and 6. But every grid has 5 degrees in it, so the period becomes 6 times 5 degrees, but this is just half a period. I have to multiply it by 2, so this becomes 60 degrees. And then t is equal to 360 degrees divided by b. So this means that 60 degrees is equal to 360 degrees divided by b. So b is 6. Okay? Now I put these constants into my function. Y becomes -2, sine b is 6x plus c degrees, and then I have d equals to 1. Okay, Now, in order to find C, I have to compare this function with the standard trigonometric function. But now, because this is negative, I will compare this function with the function minus sine 6x. Again, in order to do that, I need to know the standard sine function, and then using that, I need to be able to construct minus sine of 6x. Okay, so let us do that. Okay, so here is the standard sine function. So this is the graph of the function y equals to sine of x. But here I need to have sine 6x, so I have to squeeze everything by a factor of 6 along the x direction. So what does this mean? This means, for example, this number will be 180 divided by 6, so this is just 30, and this will be divided by 6, 15 degrees, so this becomes minus 15 degrees, this becomes minus 6 degrees, and etc. I think I made a mistake here. So if I divide this by 6, it becomes minus 30, so that is why it doesn't work. So this becomes minus 30, that's minus 45. Yes, it seems to be right. Okay. But now let us try to understand how much is the shift. But be careful, this is the standard sine function. But I need minus sine function because of this minus sign. So if I multiply this by minus sign, it means that I will reflect the graph about the x-axis. So this part will go down. So I have to find the mirror image of the green curve with respect to the x-axis. So this goes here, and then this goes there, yes? Something like this. Okay, now what you see the first crest on the left hand side occurs at minus 15. But what is the first crest on the left hand side of my graph? So here is minus 10, sorry, here is minus 5, and here is minus 10 degrees. Okay, so let me write this there so that we are not confused. So here it is minus 10 degrees. Okay, so the graph here, the first crest occurs at minus 10, but in my graph now, the first crest occurs at minus 15. So this means that I have to shift this graph 5 degrees to the right. Okay, so it is 5 degrees to the right. Because it is 5 degrees to the right, so this means the shift is negative 5, because the shift is towards the right. Okay, this is by comparison. What about calculation? To calculate, I have to factor a 6 out, so y becomes minus 2 sine. I factor a 6 out, it becomes x plus c degrees divided by 6, and then plus 1. So the amount of shift from calculation is the number which is added to x, which is this one. And this becomes minus 5 degrees. But if you remember, I changed my strategy a little bit from what I told you during the lesson. It is better to actually find all of them. Yes? And then choose the one asked in the problem. So here, this one is acceptable. We learn it from comparison. But I can add any multiple of the period of my function to it. So what was the period of the function? It was 60 degrees. So I add any integer multiple of 60 degrees. I am looking for c. I multiply everything by 6, so it becomes minus 30 degrees plus n times 360 degrees. I can simply drop the degree signs from everywhere, so they become pure numbers. Okay, So this is the set of all possible values for C. If there is no constraint, you choose any one of them you want and write the answer. That is quite okay. But now I want to find the greatest negative one. Okay, so I am looking, for example, if I put 0, I get minus 30. But if I put 1 and onwards, I will get positive values, which I don't know. And if I give more negative values, I will go below minus 30. But because the problem is asking for the greatest negative number, I understand that I have to choose 0. If I choose 0, then C becomes minus 30 as a pure number, but the problem is asking about A plus B plus C plus D, and then what happens here, it becomes minus 2 plus D plus B is 6 plus C is minus 30 and plus D is 1. So the answer simply becomes minus 25. And of course the period of the function, you have to be careful. The period is related to the a value, but the magnitude of the a value. So it is not minus 2. So you have to be careful that the amplitude should be expressed with positive number. Okay, that is also the solution to this problem. Okay, finally the last problem, question number 3. Consider the following functions. F of x equals to a sine kx plus 5 plus d, g of x equals to a sine kx plus 5 plus 40, where a and k are both positive and phi is the smallest possible positive value. If 105 degrees and 3 is the maximum point of the graph of f with the smallest positive x-coordinate, and 85 degrees and 4 is the maximum point of the graph of g with the smallest positive x-coordinate, then 3a plus 2d plus k turns out to be 12. We want to find phi. And of course, you remember, phi is the smallest positive value. Okay, so if I want to maximize f, because a is given to be positive, I have to maximize this sign, and the maximum sign is 1, so the maximum of f simply becomes a plus d. So f max from the calculation is simply a plus d, but on the other hand, maximum of f is given to be 3. So these two numbers should match. G max is equal to, I have to put 1 instead of sign to maximize g, so maximum of g is just simply a on the one hand, and according to the information in the problem, it is just simply 4. Okay, so then I can see that instead of a, I put 4 plus d is equal to 3, so then it means that d is indeed minus 1. Okay, okay, and a also 4. But then of course I can go to this relation. Instead of d I put minus 1, instead of a I put 4, and then I find k. So it becomes 3 times 4 plus 2 times minus 1 plus k is equal to 12. So 3 times 4, 12 are gone, so k becomes simply 2. Okay, so if I write my function f of x once more, a is 4, sine k is 2, phi is still not known, d is minus 1, and g of x is equal to a, which again is 4 sine kx plus phi plus 40 degrees, and then I have that. That is my g of x. Okay? So, one thing that now I can use is one of these pieces of information. These are not independent ones, so they will not give rise to two different values. Because if I ask you how G and F are connected, so you can see that between these two you can factor a 2 out, so it becomes x plus 20 degrees. And then if you compare this one with that one, you can immediately see that G of x somehow is a shift of the graph of f of x 20 degrees to the right. Of course, it is also shifted 1 unit upward. Okay, so it means, and of course you see that they differ only by 20 degrees, so we cannot use both of them. I mean, they will not give independent equations. So let me use one of them. For example, let me take this one and put it in the function g. X coordinate is 85 degrees and the y coordinate is 4. So instead of g, which is the y coordinate, I put 4 equals to 4 sine, instead of x I put 85, but I multiplied by 2, it becomes 170 degrees plus 5 plus 40 degrees, but 170 degrees and 40 degrees becomes 210 degrees plus 5. Okay, now I divide both sides by 4, so it becomes 1 equals to sine 210 degrees plus 5. Okay, and I want to find the smallest possible value for phi so that the number becomes 1. So if I draw the unit circle, for example, okay, so this is the unit circle. Where is 210 degrees, or sorry, where is 210? 210 is 30 degrees after, so let me consider this 30 degrees. So here is 210. But my goal is to go and reach to sine equals to 1. So it means the y coordinate should be 1. So I have to go forward until I reach to the highest point of the unit circle in which the y coordinate is 1. So how much I should travel? So from here to here is 180 degrees, and this one is 60 degrees. So it means that I have to go 250 degrees more. So the smallest possible phi is 240 degrees. Yes, and that is the answer to this problem that we have to write. But of course, because the degree sign is already given up there, what I just type here is 240. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.